Hello, my dear students. Consider the following reaction. Sign of delta H, delta G and delta S for the above reaction will be. Given reaction. The reaction takes place in the presence of air. So it is considered as a combustion reaction. For combustion reaction, the value of delta H is equals to negative. Calculate delta S value. Delta S 15 by 2 gaseous particles, reactants 7.5 moles of gases are converted to 9 moles of gaseous product. Left to right, number of moles of gaseous products are increases. So it is considered as a that for this the delta S value is equals to positive. And delta G, how to calculate delta G? Delta G is equals to delta H minus T delta S. Delta H value is negative minus T into delta S value is equals to positive. Minus into plus minus. Minus into plus is equals to minus. So finally you will get for example this value is minus 2. This value delta S value you can assume as plus 2. Randomly I am taking. Then you will get minus 2 plus into minus minus 2t. You will get negative answer. So delta H value negative, delta S value positive, delta H value negative, delta G value, after that delta G value is given, delta G value is also negative, delta S value is positive. So based on that, second option correct. Enthalpy of atomization. Enthalpy of atomization, the value of delta H is equals to positive. Enthalpy of fusion temperature, the value of delta H is equals to positive. Delta H value is equals to positive. Enthalpy of solution, the value of delta H is maybe negative or positive. Enthalpy of condensation, the value of delta H is always negative. Enthalpy of formation, the value of delta H is equals to negative or positive. Here what is the question? From the above list, identify how many always have the enthalpy change to be positive. Only enthalpy of atomization, enthalpy of fusion, delta H value is always positive. For remaining processes, the value of delta H, this is the value of delta H. Which reaction of xenon compound is not feasible? Not feasible means nothing but non-spontaneous. XeF4 plus H2O. It is a spontaneous reaction. XeF2 plus H2O. XeF2 plus H2O, spontaneous reaction. XeF6 plus RBF. It is also spontaneous reaction. This is non-spontaneous reaction, not feasible. Why? Because xenon fluorides are highly reactive towards water and undergo spontaneous hydrolysis to form xenon oxide and HF. So a reverse reaction is spontaneous. Backward reaction is spontaneous. So forward reaction is considered as non-spontaneous reaction. Fourth option. The purest and thermodynamically most stable allotrope of carbon respectively are purest form of carbon. The purest form of carbon is fullerene. Thermodynamically most stable. Thermodynamically most stable is graphite. Second option is correct. Because for graphite enthalpy of formation value is equals to 0. Diamond is very hard, not thermodynamically most stable. Why? Because diamond enthalpy of formation value is 1.9 kilojoule per mole. P molal solution of a compound in benzene has mole fraction of solute is 0.2. The value of P is the relation between molality and mole fraction is equals to molality by molality plus 1000 by molecular weight of solvent. Now, mole fraction value is given as 0.2 is equals to P by P plus 1000 by, what is the solvent here? Benzene is the solvent, 78. Now simplify. 0.2 is equals to P by P plus 12.82. Cross multiply. Then 0.2 into P plus 12.82 is equals to P. 12.82 is equals to P minus 0.2P. Then P is equals to 12.82 by 0.8. Sorry, here into 0.2. Into 0.2. Simplify, then you will get 3.2. Correct order of acidic strength of oxy acid of phosphorus. Generally, acidic nature is directly proportional to oxidation state of central atom. But in case of oxoacid of phosphorus, oxoacid of phosphorus, in case of oxoacids of phosphorus, the acidic nature is inversely proportional to basicity. So, third option correct. H3PO2 basicity. H3PO2 basicity, number of replaceable hydrogen atoms 1. H3PO3, number of replaceable hydrogen atoms 2. H3PO4, number of replaceable hydrogen atoms 3. For a reaction, N2 plus 3 moles of H2 gives rise to 2 moles of NaH3. The rate of disappearance of H2 is given by, first of all, rate of forward reaction. Forward reaction rate is equals to K1 into N2 into H2 whole cube. Rate of backward reaction. Backward reaction, now NH3 is the reactant. So K2 into NH3 whole square. The net rate of reaction, because it is a reversible reaction. Given reaction is a reversible reaction. So the net rate of reaction Rate is equals to rate of forward reaction minus rate of backward reaction. K1 into N2 into H2 whole cube minus K2 into NH3 whole square. Rate of disappearance of H2. Now write a rate for this equation. Rate is equals to minus dN2 by dt is equals to minus 1 by 3 dH2 by dt is equals to plus 1 by 2 dNH3 by dt. Now the thing is disappearance of H2. With respect to H2, in the place of rate, write minus 1 by 3 dH2 by dt. Minus 1 by 3 dH2 by dt. But question is minus dH2 by dt. Minus dH2 by dt is equals to 3 into K1 into N2 into H2 whole cube minus 3 into K2 into NH3 whole square. So second option correct. CCl bond is stronger than ClCl bond. Here ClCl bond length is given 199 picometers. CCl bond length is 177 picometers. Bond length is inversely proportional to bond energy. Based on this, first statement is correct. CH bond length. CH bond is stronger than CCl bond. Yes, this statement is also correct because CH bond length is 107, CCl bond length is 177 picometers. Bond length is inversely proportional to bond energy. Based on that, both the statements are correct. A current of 2.6 amperes passed through CuSO4 solution for 6 minutes 20 seconds. Current is given in terms of amperes, so time is taken in terms of seconds. So total number of seconds 6 into 60, 360 plus 20. Total time is 380 seconds. Weight is equals to question mark. Equivalent weight. Equivalent weight is atomic weight by valency. CuSO4 dissociate like Cu2 plus SO4 2 minus. So divides with 2. That is equals to 32. Now use the formula. Weight by equivalent weight is equals to IT by 96500. Then weight is equals to equivalent weight into I into time 380 by 96500. Now simplify. Then you will get 0.327 grams, nearly equals to 0.33. In both DNA and RNA, heterocyclic base and phosphate ester linkages are at base is at C1 position, phosphate is at C5 position. Third, third option correct. Hydrogen oxygen fuel cell is with an energy efficiency at 70%. The enthalpy of formation of H2O is equals to minus 286.5 kilojoule per mole. The amount of electrical energy generated by the fuel cell with the consumption of 4 grams of hydrogen in kilojoules is, first of all, amount of electrical energy generated. Amount of electrical energy generated. What is the meaning? Means magnitude of energy produced. Magnitude of energy produced. Not the sign. Don't consider the sign. Why? Because Here question is energy output. How much amount of energy is released? Energy output. Always taken as positive quantity. Remember this point first of all. Now the formula is electrical energy, fuel cell efficiency. Question, fuel cell efficiency. Fuel cell efficiency means electrical energy is equals to efficiency into total enthalpy change. Total enthalpy change. Here question is for 4 grams of hydrogen. What is given? Delta HF is equals to, take positive quantity, 286.5. Enthalpy of formation means formation of 1 mole of product. Formation of 1 mole of product value is 286.5. But here question is fuel cell with the consumption of 4 grams of hydrogen. Number of moles of hydrogen. How many number of moles of hydrogen involved? Weight by molecular weight. 4 by molecular weight of hydrogen 2. That means 2 moles. 1 mole 286.5. Then 2 moles how much? Enthalpy of formation value. Nothing but 2 into 286.5. Substitute here. Here given 70% efficiency. 70% efficiency means 70 by 100. 70 by 100 value 0.7. 0.7 into 2 into 286.5. Simplify, then you will get 401.1 kilojoules. Second option correct. In the reaction, CO plus half O2 gives rise to CO2. N2 plus O2 gives rise to 2 moles of NO. 10 ml mixture containing CO and N2. 10 ml mixture containing CO and N2. So let the volume of CO is equals to X and the volume of N2 is equals to Y. Total mixture volume X plus Y is equals to 10. X plus Y is equals to 10. Now read the question. 7 ml oxygen to form CO2 and NO on combustion. The volume of N2 in the mixture will be. Okay. Now oxygen required. From this reaction, X ml of CO requires X by 2 ml of O2. 1 ml of CO requires 1 by 2. 1 mole of CO required 1 by 2 mole of O2. So based on that, X ml of CO requires X by 2 ml of O2. And according to this reaction, 1 mole of N2 required, 1 mole of O2. That means Y ml of N2 requires YML of N2 requires YML of O2. So based on this, now X by 2 total O2 used is 7 ml. That is X by 2 plus Y is equals to 7 ml. Okay. According to this, either you can calculate. According to this can be written as X is equals to 10 minus Y. This is equation 1. This is taken as equation 2. Equation 1, substitute in equation 2, then X by 2 plus 10 minus Y is equals to 7. Sorry. X plus 10 minus Y, substitute. 10 minus Y by 2 plus Y is equals to 7. So simplify. LCM is 2. 10 minus Y plus 2Y is equals to 7. So 10 plus Y is equals to so 10 plus Y is equals to 14. Y is equals to 4 ml. Y is nothing but N2. Question is related to N2. Third option correct. Consider the following reaction in basic medium. NH3 plus OCl minus gives rise to N2H4 plus Cl minus. The coefficient of N2H4 in the balanced equation will be. First NH3 is converted to N2H4. N factor value is equals to 1. OCl minus is converted to Cl minus. N factor value is equals to 2. Exchange the N factor value. Exchange the coefficients. Then 2 moles of NH3 plus OCl minus gives rise to N2H4 plus Cl minus. Remaining 6 oxygens, here 6 hydrogens, here 4 hydrogens, 2 hydrogens, 1 oxygen, H2O form eliminated. What is the question? The coefficient of N2H4 in the balanced equation. Equation is balanced. How many moles of N2H4 here formed? 1 mole of N2H4 is formed. The standard reduction potentials for two reactions are given below. The value of solubility product of silver chloride under standard conditions of temperature is solubility product of silver chloride AgCl. AgCl is a AB type of salt. It dissociate like Ag plus Cl minus. Which ions are formed as product? Ag plus ions and Cl minus ions are formed as a product. In the first equation, Cl minus is a product. So first equation is right as it is. AgCl plus electron gives rise to Ag plus Cl minus. E naught value 0.21 volts. And one more product is Ag plus ions. But in the second equation, Ag plus ions are in the form of reactant. So reverse the second equation. Ag gives rise to Ag plus electron. Reverse the reaction, then change the sign. Ag get cancelled, electron get cancelled. AgCl gives rise to Ag plus Cl minus. E naught value. Calculate the E naught value. E naught value is equals to minus 0.59 volts. Now calculate Ksp. Solubility product equation is in standard conditions. Generally, nearest equation E is equals to E naught minus 0.0591 by N log Kc. Equation is in equilibrium, so E value is equals to 0. E naught minus 0.0591 by N log Kc. Then E naught is equals to 0.0591 by N log Kc. What is the E naught value? E naught value is equals to minus 0.59 is equals to 0.0591 by how many number of electrons? Ag converted to Ag plus 1 electron log Kc or Ksp, whatever it may be. Then log Kc is equals to minus 0.59 by 0.0591. Simplify, you will get nearly minus 10. Then Ksp is equals to Kc is equals to 10 power minus 10. First option correct. Assertion PCl3F2 has zero dipole moment. Correct. Reason, fluorine atom is present at axial position. Correct. According to Bend's rule. According to Bend's rule, phosphorus, more electronegative atoms must be present at axial positions. Less electronegative atoms present at equatorial positions. A and R are true. R is the correct explanation of A. Consider the following graph. Choose the correct option. This graph is related to freezing point, depression of freezing point. So depression of freezing point is equals to T2 minus T1. First option correct. Ksp of sparingly soluble salt MOH twice is 10 power minus 16 m cube. Molar solubility of MOH twice in 0.1 molar KOH will be. So Ksp is equals to M2 plus into OH minus ion concentration whole square. Ksp value is given as 10 power minus 16 is equals to, observe the point, in KOH MOH twice common ion is present. OH minus is common ion. So according to common ion effect, OH minus ion concentration is taken as 0.1 molar. This is M2 plus. M2 plus is nothing but solubility 0.1 whole square. Then solubility is equals to 10 power minus 16 by 0.1 whole square, that is equals to 10 power minus 14. So third option correct. How many of the following species are amphiprotic? Amphiprotic means to donate H plus ions and accept H plus ions. H2PO2 minus readily accepts H plus ions and it is converted to H3PO2, but it is further does not donate H plus ions. Why? H3PO2 basicity value, basicity of H3PO2, number of replaceable hydrogen atoms only one. Already one hydrogen is replaced. One more hydrogen replacement is not possible. HCO3 minus accepts H plus ions and donates H plus ions and it gives CO3 2 minus. NH3 accepts H plus ions, forms NH4 plus ion, donate H plus ion and it forms NH2 minus. HCOOH accepts H plus ions but does not donate H plus ions. H2PO3 minus accepts H plus ions as well as donate H plus ions also, and it is converted to HPO3 2 minus, because H3PO3 basicity value is equals to 2. It is able to donate 2 H plus ions. Based on this, correct answer. The correct answer is 3. Fourth option. In hydrogen atomic spectrum, a series limit is found at 1 to 186.3 centimeter inverse. Then it belongs to. First of all, series limit, or this is also considered as limiting line. Limiting line. The value of N2 is taken as infinity. N2 value is infinity. Now, what we know, according to Rydberg's equation, based on the units, what are the units? Centimeter inverse. That is, this is wave number. Nu bar is equals to R into 1 by N1 square minus 1 by N2 square into Z square. Nu bar value is given as 1218.6.3. R value, Rydberg's constant 109677.8. Calculate N1 value 1 by N1 whole square. 1 by N2 is nothing but 1 by infinity whole square. For hydrogen atom, Z value is equals to 1. 1 by infinity value is equals to 0. Now, 1 by N1 square is equals to 12186.3 by 109677.8. N1 square is equals to, you will get 9. N1 is equals to 3. For Lyman series, if it is Lyman series, N1 value is equals to 1. Balmer series, N1 value is equals to 2. Paschen series, N1 value is equals to 3. So the correct option is third option. The activation energy of one of the reaction in biochemical process is, activation energy value is given, EA value is given as 532611 by 2.303. Activation energy value is given in terms of joules. So R value, take it in terms of joules. When the temperature falls from 310 kelvins, T2 value 310, T1 value 300 by 310 into 300. The change in rate constant observed is K 300 is equals to X into 10 power minus 3 K 310. The value of X is. Okay, now you can simplify this. Simplify, then you will get log K2 by K1 is equals to 2.991. This 2.991 is also taken as 3. Log K2 by K1 is equals to 3. Then K2 by K1 is equals to anti-log of 3. Anti-log 3 value 10 power minus 3. It can be also written as 1 into 10 power minus 3. So, second option correct. For a first order reaction, A gives rise to B. The rate constant K is equals to 5.5 into 10 power minus 14 second inverse. The time required for 67% completion of a reaction is X into 10 power minus 1 times the half-life of reaction. The value of X is. Okay. T 67% value calculate. Simplify 2.303 by K value 5.5 into 10 power minus 14 log of 100 by 100 minus 67, remaining 33. Simplify, and then 33 how many times? 3.5 3.3 times. 3.03 times. That means here you can take nearly 3. So T 67% is equals to 2.303. Log 3 value is given as 0.4771 by 5.5 into 10 power minus 14. Then you will get, simplify this, 1.0987 by 5.5 into 10 power minus 14. This is T 67% value. Now half lifetime. For a first order reaction, based on the units, it is a first order reaction. For first order reaction, T of is equals to 0.693 by K. T of is equals to 0.693 by K. K value is 5.5 into 10 power minus 14. This is taken as equation 1. This is taken as equation 2. Equation 1 by equation 2. Equation 1 by equation 2. Then 1.0987 by 5.5 into 10 power minus 14 into 5.5 into 10 power minus 14 by 0.693. Get cancelled. 1.0987 1.0987 by 0.693. Simplify. Then you will get 1.5854. It can be written as 15.8854 into 10 power minus 1. X into 10 power minus 1. X value is 15.854, nearly equals to 16. Identify the wrong match from the following. C4, that means CH3COOH NaOH, phenolphthalein. Correct, because it is very strong base. For strong bases, the suitable indicator is phenolphthalein indicator. Second option, B2 HCl NH4OH. HCl is strong, create acidic solution, so methyl orange. C2, no, methyl red indicator, not methyl orange. Methyl red is also correct. HCl versus NaOH. HCl versus NaOH, you can use methyl orange. Both are strong acid or strong base. This is weak acid and weak base. For weak acid and weak base, what is given? Any indicator? No, there is no suitable indicator because both are weak. Select correct statements from the list given below. The energy of 2s electron in sodium is lesser than that of potassium. Wrong, because sodium and potassium both are belongs to same period elements. In same period elements, that's the reason sodium energy of 2s electron is more compared with potassium, because the atomic number Z increases, the nucleus exert a stronger attractive forces on the electrons, pulling them closer and lowering their energy. Schrodinger's wave equation cannot be easily solved for a multi-electron atom. Correct. Splitting of spectral lines in a strong electric field is called Zeeman effect. Wrong. Strong electric field is called Stark effect. Stark effect, not Zeeman effect. Splitting of spectral lines in the presence of magnetic field is called as Zeeman effect. So this is wrong. The spectrum given by helium gas is line spectrum. Correct. BD correct. Wrong match is, first one is correct. Cross aldol correct. Second one, yes, this is Itard reaction is given, but this is wrong. Wrong match is second one, because in Itard reaction, what is the reagent? CrO2Cl2 in CS2. Which one of the following is expected to exhibit optical isomerism? Optical isomerism. First two are square planar complexes. Coordination number is equals to 4. Square planar complex exhibits geometrical isomerism. For optical isomerism, chiral carbon atom is required. Chiral compound must be chiral. This is achiral. That's the reason it exhibits geometrical isomerism. Here coordination number is equals to 6 because En is bidentate ligand, so coordination number 6. We know that trans compounds does not shows optical isomerism, does not exhibits optical isomerism. Why? Due to presence of plane of symmetry. So based on that, correct option is third option. Assertion C6H5N2Cl is more stable than C2H5N2Cl. Yes, aromatic diazonem salts are more stable than aliphatic, because in aromatic resonance is possible. Both A and R are true. R is the correct explanation of A. 1,2 dibromopropane on treatment with X moles of NaNH2. Yes, this is haloalkane. That's the reason NaNH2. Here NaNH2 acts as dehydrohalogenating agent. It removes hydrogen and halogen. So 2 times dehydrohalogenation takes place. So you can use 2 moles of NaNH2. Then it gives CH3 C triple bond CH. Now alkyne reacts with NaNH2. Now NaNH2 is reacts with acidic hydrogens also. Then it gives CH3 C triple bond CNA, C minus Na plus. It reacts with C2H5Br. Then it gives CH3 C triple bond C CH2 CH3. Yes, pent 2 ion is formed. How many moles of NaNH2 is used? 2 plus 1, 3 moles of NaNH2 is used. Carboxylic acid reacts with PCl3. What is the role of PCl3? It breaks the bond between carbon and OH group. Break the bond between carbon and OH group, then it gives CH3 CH2 COCl. Acid chloride is formed. Acid chloride is reacts with a benzene. The process name is called as Friedel-Crafts acylation. Friedel-Crafts acylation takes place and it gives C6H5 CO CH2CH3. Now it is ketone. Ketone NH2 base. NH2 is used. The process is called as Wolff-Kishner reduction. Wolff-Kishner reduction, then carbonyl compounds are converted to alkanes. Based on that, the correct option is first option. Which of the following statement is incorrect? Many trivalent lanthanide ions are colored both in the solid state and in aqueous solution. Yes, this is correct statement only. The first ionization enthalpies of the lanthanides are around 600 kilojoule per mole. The second about 1200 kilojoule per mole, comparable with those of calcium. Correct. The actinide resembles the lanthanides in having more compounds in +3 state than +4 state. Only +3 state. This is incorrect. Thorium shows variable oxidation states. The actinide resembles the lanthanides ion having more compounds in +3 state. More compounds are in +3 state than +4. Sorry, third statement is correct. Thorium shows variable oxidation states +4, +5, +6. Wrong. Thorium shows +4 oxidation state. Fourth option. How many of the following compounds gives positive Fahrenheit test? What we know? Positive Fahrenheit test. Aliphatic aldehydes gives positive result. Aliphatic aldehydes only. This is aromatic aldehyde, so negative. This is aliphatic aldehyde, positive. This is ketone. Ketone gives negative. This is also ketone, negative. Methanol aldehyde, positive. This is aromatic, negative. This is again aliphatic, positive. 1, 2, 3. Second option correct. Correct stability order of +6 oxidation state of elements is represented by first option. Because chromium, molybdenum, tungsten group elements, groups top to bottom, stability. I am talking in case of only D block, not in case of P block. Only D block. The stability of higher oxidation state increases. Paramagnetic species in the above. First of all, CO exhibits all cases +3 oxidation state. NH3 strong ligand field, so it does not follows Hund's rule. 1, 2, 3, 4, 5, 6. Unpaired electrons are absent, so it is diamagnetic. Even here also strong ligand field, unpaired electrons are absent, diamagnetic. H2O fluorine minus are weak ligand fields, so unpaired electrons are present. Unpaired electrons are present, so it is paramagnetic. So B is paramagnetic. D is also paramagnetic. BD. BD option is not given. Okay. Remember, B also not possible. B is also diamagnetic only. Why? Cobalt. H2O combines with cobalt. It acts as strong ligand field. So only D is correct. This is the exception condition. Generally H2O is weak ligand, but H2O combines with cobalt, it acts as strong ligand. Match the following. Methane reacts with oxygen in the presence of copper. Then it gives methyl alcohol CH3OH. Alcohol A3. Alkene undergoes ozonolysis. Break the double bond. Left side oxygen, right side oxygen. Then it gives only aldehydes. B4 A3 B4. Yes. KMnO4 by H plus. Cr2 group is oxidized to ketone. In the previous video I explained clearly. And CH3 undergoes oxidation, then it gives carboxylic acid. Assertion. Preparation of ethers by acidic dehydration of secondary and tertiary alcohols is not suitable method. Correct. Dehydration of secondary and tertiary alcohols to give ethers is unsuccessful as elimination competes over substitution to form alkenes. Both A and R are true. R is the correct explanation of A. Electron gain enthalpy values are positive. Remember, electron affinity to second electron affinity is positive. For 2A group elements, for 2A group, EA1 is positive. Generally EA1 is negative, but 2A group EA1 is positive. Not only 2A group, for 5A group also electron affinity 1 value is positive. Because 2A and 5A group elements electronic configuration is most stable electronic configuration. So we can supply some amount of energy, then only addition of electron is possible. Here 2A group, so positive, 5A group positive, O converted to O2 minus, that means this is electron affinity to positive. So ABC positive, remaining cases negative. Reactive towards SN1 reaction. First one, why? Because a heteroatom at alpha position increases the reactivity of SN1 because here resonance is possible. Correct statements. Titanium less than manganese less than nickel less than zinc is the correct order of first ionization enthalpy. The element with atomic number 32. Element with atomic number 32 is germanium. Belongs to 4th period and 14th group. Correct. IP2 of magnesium is greater than IP2 of sodium. Wrong. After removing one electron, it gets noble gas electronic configuration. So IP2 of sodium is greater than IP2 of magnesium. Non-metallic elements are more in number than metallic elements in the modern periodic table. Wrong. Only A and B statements are correct. Consider the following sequence of reaction. 4-nitrotoluene Sn plus HCl. Sn plus HCl reduction process takes place. Nitro group is converted to amine. Then CH3NH2. NH2 group is highly activating group. To reduce the activity, it reacts with the acid anhydride. Further bromination takes place. So mono substituted bromine product will be obtained. CH3, NH2, bromine. Assuming that the reaction proceeds to completion, then 137 milligrams of 4-nitrotoluene will proceeds dash milligrams of B. Okay, this is B. Calculate the molecular weight. Molecular weight of 4-nitrotoluene is 137 grams of 4-nitrotoluene gives 228 grams of the product. Then question is 137 milligrams gives 228 milligrams. Third option correct. Statement 1. This compound can be synthesized from this compound using simple reagents in the order. Okay. Alkyl group. This is also alkyl group. Reaction with KMnO4. Side chain oxidation takes place. Side chain oxidation takes place. Then it gives COOH, COOH. Now reaction with ammonia, then it gives CONH2, CONH2. Now bromine alkali means Hoffman bromamide. Hoffman bromamide degradation, then it gives, remove the carbonyl group, NH2, NH2. So statement 1 is correct. Statement 2, for this compound converted to this compound. Okay, take the first compound, bromine water. NH2 group is electron donating group. CH3 group is electron donating group. Electron donating groups are present. Ortho and para product is obtained. With respect to CH3, NH2 is para. With respect to NH2, CH3 para. Already para position is blocked. So bromine is substituted at ortho position. CH3, bromine. NH2 is strongly activating group. So two bromine atoms are substituted at ortho position. Now NaNO2 plus HCl, diazotization reaction takes place. NH2 group is converted to N2Cl. Bromine, bromine, CH3. Now aqueous H3PO2. Yes, aqueous H3PO2, remove N2Cl. Then this compound is obtained. Both the statements are correct. Arrange the following carbanions in the decreasing order of stability. Carbanion stability to electron withdrawing group. Among these, CHO group is electron withdrawing group, minus I group, minus R group. This is minus I group plus R group. This is OCH3. OCH3 is electron donating group plus R group. CH3 group. CH3 group is also access plus I group, even plus R group also. These two are electron donating groups. So this is electron withdrawing group. Starts with 4. 4 after 1. Third option, correct option. Match the following. Bayer's test. Bayer's test is also called as Bayer's reagent test. Bayer's reagent test is for unsaturation. A4. Ceric ammonium nitrate test. Ceric ammonium nitrate test is for alcohols. Thalene dye test is for phenols. Based on this, A4, B3, C1. Fourth option correct. Acetylene dibromide. Yes, this is acetylene dibromide. Exhibits geometrical isomerism. Yes, it exhibits geometrical isomerism. Ethylene dibromide is a saturated compound. Correct. Both the statements are correct. The correct order of pKa values for the following compounds. This is alkyl group. Yes, alkyl groups are generally acts as electron donating groups. Here neither electron donating group nor electron withdrawing group. NO2 group is very strong electron withdrawing group. CN also electron withdrawing group. Starts with D because acidic nature inversely proportional to pKa, directly proportional to electron withdrawing group, inversely proportional to electron donating group. Based on that, starts with D, ends with C. Third option. Which of the following statements are true? The sign of optical rotation is not necessarily related to absolute configuration. Absolute configuration means R and S configuration. For R and S configuration, sign is not required. For D and L configuration, sign is required. Given compound is chiral compound. No. Enantiomers. Enantiomers possess dissimilar physical properties. Wrong. Possess similar physical properties. CHO, CHOH, CH2OH is an chiral or asymmetric molecule. Correct. A and D are correct. Following is incorrect. Which is incorrect statement about uranium ion? Uranium ion contains one sp3 hybridized carbon, but here given as all carbons are sp2, that is wrong. Thank you.